right, we have 2 moderators. Okay.
Awesome. All right. So goes in the 30 and out the 30. Got it. All right, so, and then it goes through the diode into 26 at the start. So, this one. And the cool thing is all this can rest right on the coil, which is like way different than the way I was doing it.
Right.
I'm going to put it like this. So we got 30. And then there's a trigger strand too. So there's a 32 gauge trigger strand. I'm gonna glue it like that. And it comes out the 26 right here. Alright, so we got our ground, we got our power in, we got our trigger strand.
How's it going, Peter?
Hey, what's up? What is up, my man? What's going on? How goes the battle?
Good. It is a good day, he says.
You see a wire. You see there's a wire there. But I think it's one of my connected ones. So we got the 26. We got the 30. Nice. That's all we really need. And then the trigger strand can or cannot be used based on, you know, whether you want to use it or not.
Nice.
The out in is south, out north. Or am I wrong about that? All of my coils were wound counterclockwise. All right, let's check this. Let's check this new motor out. This new rotor here. I'm gonna put 9 volts in. Probably gonna hook up my other power supply because that's bugging me a little bit. How touchy that is. All right. It has a slower pickup than my single file coils over there that are 16 gauge. But it gets whipping pretty good. It's a 4-magnet rotor in Celtic cross formation. I think it looks really cool once it gets going. like right here, it just looks like 4 circles that are mushed together. But through the camera, you get kind of like a reverse motion effect.
Oh yeah.
Yeah, like a bullseye. Yeah, target. Perfect.
Because it does look like it's spinning clockwise, and
Yeah, it's definitely going that way.
it's definitely spinning counterclockwise.
Counterclockwise. It does look like it's spinning this way.
Mm-hmm.
And that's 9 volts. So I'm pretty happy. I mean, I'm starting to build the coils with the trigger coil embedded, so it can be used either way. But this is the trigger coil right here, running both of these parallel, and it's great. You really can't get this with the trigger coil inside, but I'm gonna give it I'm gonna have the option, and you know, just because I want it. That's 15 volts in. Just give it a couple, like a minute, and it'll speed up. Like any voltage increase in the 16 gauge coils over there at 120, instantaneous pickup, but it doesn't go more than 750 altogether. Well, I only turn it up to 15 because it starts shaking all over the freaking place at 15 volts.
There.
A lot of power.
Now it's starting to form that cross.
Yeah. In the middle.
Mm-hmm.
Yeah. That's awesome. All right. Well, I have been cleaning up a little bit. I cleaned up like half the table. Put some wires back up on the clip of holders over there, the clips. Yeah, but I'm like beat, man. I don't even know what's going on. I'm pooped. But this is awesome. You know, getting this done. I'm tired and I'm doing this stuff anyway, so it's like.
Yeah. Hey everybody, welcome to the channel.
Hey, what's up?
Drop
How's
a
it
like,
going?
subscribe. Let us know what's on your mind. You guys like pulse motors, magnets?
Yeah, this is a 4 magnet rotor. I've been running the 9 magnet rotor on this, and it runs just as good, if not better. I would say just as good. I mean, the power isn't any different. And it moves like the Dickens, man. 9 magnets, like no sweat. But I can't have it like this. You know, I'd have to rearrange all the coils and everything to get it right. I had this one 12 magnet rotor that was like, it was actually this one. It's a 4 magnet now, but there were 12 magnets on it, and they were big, hefty magnets. And I had, you know, a 90-degree circuit, okay, for a drive. And then I had, like Adams motor style, I had a coil here at 22 degrees on each side of the north and south. And I got a video of it.
How's it going, Victory?
Hey, what's up?
Ooh, it's 234. There it is.
That. Look at that. Wow, that just opened up.
Yeah,
Like the camera is adjusting.
Yeah.
But that looks tight. We're gonna try some other stuff too.
Hey everybody, welcome to the channel.
Hey, what's up, guys? So this had, yeah, it was great. And actually there was just a 180-degree drive, and then the other two coils were latent drive coils, so it would have to be spinning for them to function. And then when you turn it off and it continued to spin, they would continue to function as long as it continued to spin. I know that's a paradox, but it's real, because the time that it would spin for was longer with the coils in the position than it was without. No joke. I got a video of the whole thing. And it might not be a big deal, but it was cool to me, you know. So what are we going to do here? I think this might work, actually. We'll try it. This is a 9-magnet rotor that I printed a while ago. Wow, these bearings are immaculate, man. This print was fabulous.
Yeah.
These have 1-inch neodymium M52 cube magnets, 9 of them. So it's like getting a reed switch, you gotta put it underneath. Can't have it right in front or it'll get all.
Hey everybody, welcome to the channel. Drop a like, subscribe, leave us a message in the comments. Let us know if you're interested in magnets and just kind of working your passion just in your day-to-day.
Alright, so we'll get one right there. I mean, I really liked how smooth that 4-magnet was moving. That was so nice. Yeah, but we're going to try a bunch of things.
Oh, I love that. Peter says, when I was a kid, I thought magnets came from the North Pole and the South Pole.
That's awesome.
Yeah.
Alright. So, should we try it like this?
I think you're talking gaps.
Yeah. It's like this is on offset, but it's not really. It's kind of...
Right on the tip.
Yeah. Should we try that?
Yeah. He's talking about magnet position at the start with this build. Oops, there's...
It is working. I just don't know to what effect. I think it can be way better. But we'll wait, because they're bifilar coils. They're a little less responsive than my single file coils. But they have longer, you know, just takes them longer to speed up, but they go faster.
Micah asked, what are we making?
It's coils. I'm making coils. I'm just testing out, and these are little bifilar coils with DC rectification, and I'm just testing them out. This is a 9-magnet rotor. We just got done testing out a 4-magnet rotor.
And then we make our own coils. All for electromagnetic field bashing.
Yeah, I don't know. I think if we move that coil over just a little bit,
It would work
we're
better.
gonna get a pow, like ping, 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 ping. It's gonna go like really fast, because it is not timed right now. I either need that or I need another trigger coil to go right here, like right next to this one, or in an offset position, and then they'll both fire at the same time, which is, I kind of want to do that anyway, but
Okay.
yeah.
Yeah. Hey everybody, welcome to the channel.
Hey, what's up? What is up? All right, I'm gonna move that one.
Let us know if you play with magnets now, if you played it with magnets as a kid.
Could you unplug that? Thank you. All right. Good move. Pull that off of there. Just gonna put it. Oh, that's not right.
Oops, sorry for the finger.
Oh man, it's suck if I have to do it again.
That's all right. We can scrape it off, brush it up.
All right. Well, yeah, we're gonna do that all for sure. Anywho, gonna spruce it all up, man. We're gonna put a new face on this thing. But we're gonna flip it over and we're gonna make it just a plain brown face, so it doesn't, like, if we pull something off, and it's not gonna look terrible. It's not for a while. All right, that did take. That's awesome.
Nice. Hey everybody, welcome to the channel.
Hey, what's up? How's it going?
Drop a like, subscribe, leave us a comment. Let us know if you're interested in magnets, pulse motors, electromagnetism, making coils.
See the difference already?
Yeah, oh yeah, oh yeah. Yeah, it's just from repositioning the coils, something. Oh, that's the bearing. Or no, what would that be? It's like a change in gear almost, right?
Yeah, I think it all just kind of synced. If it was like unsynced at all, it got forced into position.
Got it. Because now it's smooth and picking up.
Could be a bearing. It's going really fast, so I hope it's not a bearing. And that's just one trigger coil firing 2 transistors. So these are wound parallel. And I was thinking about making offset positions for like a 9-magnet rotor. So having 18 magnets, electromagnets.
Wow.
But I need, or no, actually 16 electromagnets and 2 trigger coils that are not embedded in the coils. That's the best way. Look at that. Look at that. It's 10 volts. This one has a trigger coil in it. If I hook that trigger coil up You will not get this with 10 volts. You won't.
Mm-hmm.
You have to turn it up higher.
Just want to say thank you, Peter Holofac 2.0, for moderating. Him and Mike Does are two of our moderators, and we appreciate their knowledge and help.
Indeed. Thank you. Great source of knowledge right there, those two. All right. So I was thinking, how would I set up an oscilloscope to read this coil, what it's producing as a wave? Here, let me get one. Maybe I'll work with that at a different time. It's just that this one is
I got it. Here we go. You want me to unclip it?
yeah, please. But I got it just by shimmying everything a little bit. I'm glad we didn't make contact with anything important.
All right.
All right. So let me turn this off. All right, I'm gonna need these two clips will work just fine. Because my arms, my hands are not sturdy enough. They're about as sturdy as my voice right now. So they're just not, you know, I can't hold these things where they need to be held. All right, there's our positive, and green would be our negative. All right. Could you do me a favor?
Mm-hmm.
Could you cut the power?
Yep.
Thank you.
All right.
All right, so negative, like, we'll just set it up how it's wired. And we'll see what we get, and then we'll reverse it.
And this is to look at the wave
Yeah.
on the oscilloscope. Cool.
So I got one clip to the in, the 30 gauge, and I got one clip to the 26 gauge coming out. It's just, do I have the right one clip to the right one to get the readings that we want to get? I don't know yet. See, how do you center that? I don't know how to center that, but we gotta turn the power back on.
Oh yeah. So that's. I'm chuckling to myself. All right, back to 10.
Yeah, that sounds good. All right, we got some readings over here now. And since it is just a drive coil, I wasn't expecting much. But you see how that, what is it, the y-axis? Or the x-axis is not, it's not on, the wave is not on the x.
So it's negative.
No, that's offset.
Offset, okay.
And I don't know how to put it back. That is literally like it's taking a reading below, or is it all negative? I mean,
That I've seen graphs work both ways.
but I haven't seen it move above that line in a while.
You can see the
Square wave?
in the oh yeah, there's one forming as it's going faster.
It's about 50, 67 hertz, 70 hertz. It's really fluctuating. I don't know what that is all about. 120 volt on average peaks.
Hey everybody, welcome to the channel.
Hey, what's up? How's it going?
Drop a like, subscribe, leave us a comment. Let us go. My bad, go for it.
Yeah, join with us. Come visit the Discord. We're just checking out these coils right here. These little baby Bifilar coils. Finally got them hooked up the way I wanted them to. I wanted them to function, and they're functioning great. It's like, for what they are, that's just 2,000 turns altogether in each one of those coils. I'm rolling with the trigger strand now, so they'll have a trigger strand inside of them.
Wrapped inside of the coil.
Yeah.
Okay.
With the rest of it.
And is there a benefit to doing that?
I'd say there's a benefit to running it the way there is that it is right now. There is a benefit. You get two more coils to put on the rotor.
Ah.
That's the only benefit that I can really see. I mean, there might be other benefits, but I haven't been able to like physically see them. They must be in the readings somehow.
Okay. So this is the signature of this setup.
Yeah, it's a negative wave. It's a square wave, and it's got peaks, little spikes.
Oops, there's some glare. Let's see if I can get it focused. Yeah, now you can see the numbers.
So 77 hertz. Yeah, this rotor that I got on my this rotor will generate 1,000-volt spikes at least.
Okay.
Yeah, like ridiculously large amounts of electricity for it being just a plastic circle.
So that's a great, yeah, that's on a square wave with 100 volt peaks. Is this the description of that one?
Yeah.
Yeah.
And this thing is whipping. I wish we had our tack strip on there, but we don't. And you don't need to put in so much, because the way that it's built, there's going to reach a point where it's going to start to fall apart. And when you get to that point, there's no reason to get to that point. That's what I'm trying to get.
So what kind of things happen? Like
the bearings will start to pop out. You'll get a lot of vibration in the table.
in the shaft?
Yeah, coils will go flying. At least the magnets will be solid, because I've learned how to build those better.
Yeah. Preservation of the magnet.
Yeah, I've learned how to encase those so they don't go flying.
In all of his, on all the builds, here's a couple builds. You can see them that they're encased. Those ones are glued in. And I think it's like that on both sides. Yeah. Those ones are glued in. So you can kind of
Now what we're
witness
gonna do
the evolution.
is we're going to take that 4. We should do that. We should take the 4, and we should get the wave of that off of this coil too.
All right. I can feel residual electricity running through my fingers.
Yeah, I turned it up to 15 volts, and that thing started to like just sing. And you know, when you put the trigger coil outside, you don't get the same like doot 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 as a trigger coil inside. You don't get that, but you get phenomenal speed. So I gave it an option. Either you can run it with its own trigger coil, which you got to spin it pretty quick. It's only 1,000 turns.
Can you show the underneath of that rotor?
Mm-hmm.
Who is that? Me? No. Someone like as their car's going off and it's close.
Alright, that sucks though.
So the underneath looks the same. So it's
There's a little bit of an opening here because this is I glued this on here to make sure that the magnets didn't come out. It's just a cover.
okay, so there's a cover.
You can
glue.
screw it in too. It's like each offset position is solid, so you can screw it in if that's necessary.
All right, so there's a foundation underneath that the magnets slide into, and then a cover you put on top.
Yep.
Got it.
Yeah.
Or did you want to do the 4?
Yeah. Let's do the 4. Let's get the reading on the 4. That would be awesome. Because it's supposed to be different.
Oh, I caught some passengers.
Oh, nice. The gold-plated reed switches.
Hey everybody, welcome to the channel. Drop a like, subscribe, let us know your thoughts on pulse motors, magnets, electromagnetism.
Oh, that is so greasy smooth, dude.
Yeah, that was fresh. And bouncy.
I know. Okay, so we gotta move it again.
Oh yeah, the one. Oh, wait a second.
Let me try and clear some of this off, some of the same issues.
I'm gonna plug this in to get the glue hit in.
Oh, it didn't get plugged back in?
Yeah.
Alright. So we gotta wait for a little bit. Not
Okay.
too long now. Yeah. I struggle with that because the cord's not long enough. I need an extension cord just for the glue gun. I've been struggling with that for a long time, actually.
You see, I just pulled it in. Nice.
It would stay there though.
Let's see if I can zoom in on that gap. Nice. So how many experiments do you think you run in a given amount of time? Like an hour or 2 hours?
Depends on what I'm doing. If I'm building something, not so many. If I'm playing with it, whatever I can think of, pretty much. And I'll tear something down. I'll build it up a different way. And the more pieces I have, the more vibrant the puzzle is.
We're just waiting on this to heat up a little bit so that I can pass it to him unplugged.
I know that sounds like gibberish, because it is.
Here, let's see. Okay. Got it. That's it. That's how they get sucked in, because it's all magnetic.
Yeah, and
That
yep.
copper wire with
that's good. Let's see if we got enough.
Oh yeah, iron core. Oh, nice. You're close enough. All right.
No, it's not working on.
Oh, okay, so it needs a little more heat.
Yeah, turn it up. It's up. All right. Yeah, man, I can't wait to see the sine wave on the little coil over there. And it's straight DC parallel circuit, so it's, I can either run it series, in which case I can put another directional diode in and make it more direct current. But I chose not to do that. I chose to do parallel. Yeah, these. Oh,
The glue gun's not ready.
the glue gun's not ready. This would make a great meme.
Yeah,
Like
yeah,
straight up.
yeah. Oh, yeah. There's the same amount of glue sticking.
Oh man.
So you want to describe the build real quick, or the print, I should say?
Oh, the Celtic Cross print?
Yeah.
Oh yeah, okay. It's got 3/8 of an inch gaps for 3/8 inch magnets. They're a 1/4 inch square. So I mean, for anything to work, you gotta whip it pretty good, but it works. You see, there's not much drag. When each one of these coils has a core in it, so there's not much drag, but you can center it in. Oh, it's awesome. So what I did was I wanted to make it originally I wanted to make it extend out to here, this ring, and be a little smaller, right? But then I'm like, well, then I got to put all the support on there, and it's gonna not print right. So
Yeah.
I tried to erase that the best I could, and I made the ring bigger so that it would touch. And I mean, it looks good, I think. I mean, I'll work on supports, but this just, it wouldn't take to the plate,
Right.
the support.
To that plate.
Yeah. And I gotta get a new plate anyway. But yeah, it's getting real smooth on this side over here. All that's getting pretty smooth. All right, we're gonna put it on and then we're gonna go.
Okay.
Hey, it was working. That's awesome. Yeah, I'm gonna have to hold this for a minute.
Okay.
And then I got one more to put on here, but there's nowhere to put it.
Yeah, right here, and it should be right here.
Yeah.
Hey everybody, welcome to the channel.
Hey, what's up?
Thanks for stopping in.
Heck yeah. We're about ready to blast off here.
Get a sine wave measurement on this brand new 3D printed pulse motor. Drop a like, subscribe, let us know what your passion is. Do you guys love magnets? Let us know.
Yeah, chime in.
If we are brothers and we live in Michigan,
All right, here we go. Hopefully this will all work as planned.
what's going on?
Got some reading?
Not yet. It's just kind of. Nothing.
Nothing?
Mm-mm.
Oh yeah, there's something there.
Ah, because, see?
It's just really tiny. It wasn't moving at all.
Good man.
But what is it going to end up being once it gets going fast enough?
Yeah.
Yeah, I knew it wasn't going to be much because the magnets are not strong, but they're strong. I mean, they're strong enough to make it work, but to generate a bunch of electricity, I don't think they're that strong. We're going to get a wave for sure. It's starting to form.
Yeah, that's a lot better. Yeah, there's a little bit on the top and bottom. Yep.
So I just turned it up to 15 volts, and we're getting like a steady bump. It's starting to form into 4 bumps.
Yep.
But I mean, the magnets that were in the rotor we were just using are at least, 5 times stronger than the magnets that are in here now. It does move very well.
Yeah, it does. Wow. Yeah, look at that.
Yeah, it moves really smoothly. I mean, you can even tell exactly how off that middle ring is by how it's kind of bouncing around.
Oh, yeah.
But it's, you know, it's moving graciously. I think it's great considering I eyeballed the whole thing.
Yeah, and it's levitating.
Alright, so I want to hook up the big one.
All right.
Alright. I think this is great.
Let me get another look at it.
It's nothing really, but it's great. You know what I'm saying?
Yeah, that from the 4 magnet packs. And the 4.
Yeah, we got a minor square wave.
Yeah. It's a visible signature.
Yep. It's just tiny
Mm-hmm.
because the magnets are not strong and the coils are very small. When you combine those two things, you can get some very good speed. And I think that's about it. I love this thing. It's so smooth is definitely the word to describe it. its weight even suggests that it's smooth. Now this is going to be, I'm going to have to remove the coils again, but I want to see this wave.
Welcome to the channel, everybody.
Hey, what's up? It's Papa Bale.
Thanks for stopping in.
Awesome.
So how much did you know about pulse motors when you started doing this?
Nothing. Just that I knew that you could make. I saw one video on it, and I knew that you could make something spin without spinning it manually. And that's what got me started with that. And then magnets. I've always been hooked on magnets.
Yes. I can be a testimonial for that. There was a good angle right there.
This might be too close. But I'm gonna hold it.
Let me go. It's about an 1/8, maybe a 16th.
Yeah, just if the glue doesn't
Oh,
hold.
yeah. I guess at the coil level, it's more like an 1/8.
Yeah, it's.
Oh, I saw it pull it in. Yeah.
Yeah, man, this is gonna be tricky. Forgot how I did it the last time. And now there's all this stuff here.
The troubleshooting when we're working with powerful magnets. Hey everybody, drop us a like, subscribe, let us know.
That should be way more than close enough. There we go.
If you guys want to collaborate on any projects, and if you're working with similar things yourself.
That's a big pull on there.
Yeah, you can see it moving it when the magnets go by.
Alright, this is the moment of truth, and I think it's gonna fail. Let's see. Alright, let's stop it bobbing back and forth. Let's see. Yep, it's already moving.
Yeah.
Damn. So back it way out.
More than that, yeah.
That's a good inch right there. I hope it works.
the mobile glue gun. Yeah.
I don't know. Definitely not.
There went. Yeah.
I said, yep. Just stupid, man. Why is this not sticking?
You want the scraper?
Yeah.
Where is that thing?
Underneath the thing. And that's all I'm gonna say. The case, bro. I already tried to tell you what it was before.
Okay.
Case. Yeah, that's the case.
Got it. This is just, yeah, freshen up for new experiments. And this is yeah. There's a lot of glue going through here.
Heck yeah.
Mm.
Man. Just want this to work. Nope.
Does the mallet work?
I just need
Or maybe even peel it in with your fingers.
to concentrate. Okay. Alright, there we go. I just need to not break any of the wires.
You did a great job not breaking the wire.
And this coil doesn't have a trigger strand in it, so maybe we'll just swap the coils. I don't know if that will help at all. Yeah, I don't know, man. About the mallet and all this, I'm probably gonna end up breaking a wire like this. But I need to get it off.
Oh, I see. Just get it to start and see if you can feel it. Because, yeah, you're right. You chisel that all the way down. All right, now I can hold it again.
But it's all the way down.
Oh, you got it?
It's not all off, but it's
Oh, how about,
flipping it over.
yeah. Nice. Nice work.
It's pretty good.
Okay.
It's not perfect. One more time.
Yeah.
Oh yeah, we shouldn't again.
Okay. Nice work.
Yeah, there's some of that stuff is just stubborn. Stubborn. Oh, and this might actually be, haha, look at that. Oh, hell yeah. We're gonna get this. This bad boy can generate some power. No, I hope it's not too close.
Looks like about a half an inch. Maybe a little more than that.
Is it in still? Yeah, it's still. I think we got it. Rick. Baba.
Yeah, man, if you can like hold something and then do the rest of your life with your left hand while you're holding something.
Then you are gifted.
Yeah. It's like all. Well, yeah, I guess when you're holding your kids, that's one way where it happens, where you are working with
I need
one
a glue
hand.
stick.
Stick.
Stat.
Get in there. Go in your home. All right.
Heck yeah, we got this. We got it. There it is. If that fails, we know what to do.
That's right.
Now we're definitely going to make sure our connections are good before I frickin' do anything with this.
Hey everybody, welcome to the channel.
We're going to see when this hits 88 miles per hour.
Yeah. Drop a like, subscribe. We're trying to get a live going every other day. Let us know if you have any suggestions or want to collaborate on any magnet pulse motor projects.
So this is good, and this is good. This is good. All right, here's the trigger strand for the inside one. And we can take a look at that if you guys want after we're done doing this. Now, I feel like it has a longer pickup time.
Than it did before?
No.
Or just with these coils?
Just with these coils than it did over there in the other shaft.
Okay.
Yeah, we're coming around here. It's starting to pop up a little bit. And then I should pop one of my generator coils up over here and see if we can't even get a better sine wave. Because that's definitely square with some spike.
Yeah.
Wow, man, it makes me, like some of the experiments that I've done, the spikes have been up to around 15K voltage.
15K. Up in over here.
Yeah, the peak voltage. Peak to peak.
Oh, okay, got it. Vlados, let me see if I can translate. Alright, I'm gonna take that too. I don't have a translator in here. Can you translate to English? I'm gonna see if maybe there's a setting. But pulse motor for sure. I'm betting this. It's asking what are we doing.
I don't know. M.P.H knows.
Mm. Ooh. Kids.
So that's 15 volts in. 2 bifilers hooked up in parallel with the single trigger coil right here. So I can line them all up on set all around here, and then I can get one offset trigger coil and line them all offset, and it'll work twice as good.
Hey everybody, welcome to the channel.
But you see how much less time it took that wave to get defined before, so you could read it.
And there's the signature. Yeah, that's defined. It's beautiful.
And I guess the bigger coils give you a bigger reading. So I think we're going to hook up one of those coils over here and get a reading on it. Yes. Oh yeah, that's got torque on it. Like a lot more forward momentum than it usually does.
Nice.
Okay, so we'll take this one. We're cannibalizing now.
No, that's fastened on there.
Yeah, that's the best one I got. This one? Let's see. Go. Pretty on there.
That sound. Yeah.
Dingleberry of glue.
Can you get your sister real quick?
Alright, so we're gonna get that little nubby off there. Get it as smooth as we can.
He's here. Hello.
Do you know what that sounds?
I don't like the first two words of it. It's probably not even correct. Because it could be used in different ways.
Okay. Yeah, we're We're looking for a translation on that, Lados. But welcome to the channel.
Yeah, welcome. We appreciate you being here.
Thank you.
Mm-hmm. It's cake too.
Careful.
So I wanted to go. Oh, actually, I can go in between the two coils. I hope. I can go just right there. Path.
How's it going, Norlita? What are y'all making?
Right now I'm trying to get a sine wave reading off of this 18,032 gauge coil. 18,000 turns.
In our pulse motor setup.
Yeah, it's got to be about 320 ohms. A coil.
Have you ever worked with pulse motors or magnets before, Norlita? Oh, right in between them. Wow, bro. Nice work.
Yeah. Should be good. Oh, please don't tell me I joshed it right there. Alright. Put it offset like that and let it glue. Cure a little bit.
Lados, we're working on translation.
So this one is a totally isolated generator coil. Almost like a transformer. It should have a pretty nice wave. Oh, what time is it?
330.
Oh yeah, look at this. Look at this fancy stuff right here. See, if it was centered, it'd be perfect.
Oh, waves.
You got the spike.
Yeah.
It's a positive spike though. Oh, I see an HO there, bro. I recognize that one.
Yeah, I'm sure it means something different in another language. Hey everybody, welcome to the channel.
Hey, what's up?
And drop a like,
Oh, I
subscribe.
think does that say brilliant down there?
Yeah.
That's got to say brilliant. And then the next one, I'm not sure, but brilliant is like representational in a lot of languages, apparently.
If anybody's willing to drop Vlados's comment in the translator and let us know what he's saying, he or she, excuse me.
Yeah, man, this wave is phenomenal. And I'm sure that if I plugged it into any circuit that I could hook into a loop, this coil will be able to power the whole thing. You just have to have the pulse motor running, and this coil will power that whole loop. Light, other pulse motor. I'm not sure if it'll do another DC motor, but it'll do a pulse motor DC. I've been dying to see if it'll do this fan. It will turn the fan on. Just this coil right here will turn my fan on. Between 250 and 320 spikes. Might have been what it was before. Yeah, I'm getting kind of exhausted. How about you, bro?
Yeah. But I'm good to go.
All right, let me get this cooked up. Yeah, it's really hot out there. Now that we know we got a good sine wave on this thing, let's see if it will start the fan. It's a direct loop, just coil in the fan. We're going to jack it up to 20 volts. Nothing so far. Yeah, I got the right plugs on there. The fat one is the N line, and then the little one is the live line. So they're right. But if we can't get the fan going, we'll put the light on. Cut some lights out in here, and we'll turn the 1000-watt LED on. Yeah, nothing. It's all right. I think I need a capacitor to make a fan run, or even a motor to run. I'm talking like a DC motor that you would buy at the store, or an AC motor, either one.
Hey everybody, welcome to the channel.
Hey, hey. What's up? Here we go. Here's the what I'm looking for. And we're gonna take these off of here. Got it.
Drop a like and subscribe. Leave us a comment. Let us know if you got any questions about what we're doing. And we're English only right now until we learn how to build translators into this.
All right. Now,
Hey Vlados, thank you. Thank you for doing that.
thank you very much.
We love the home hobby, fashion building, experimentation style stuff.
It's proven to be very fun so far. And I've even gotten shocked like 3 times with like 300 volts of AC.
It's hard. It's hard to do. You learn that was a short phase, but it was a phase.
All right, so why are we getting so much less power?
Is one of those backwards?
No, it's because the torque on these coils over here was kept it going so much. I don't know what the difference was, but the light was so much brighter when it was over here.
That's true. I remember that. It was much brighter than that. Hey everybody, welcome to the channel. Thanks for stopping in.
Hey, what's up? Let's get it up there. And let's get some tachometer readings. Yep, only 572. And I mean those coils would get it up to like 750 in like 3 seconds. 624. 628. But we are now 30 volts in. So I doubt that it would be this rotor that was going to be used with the little coils, though.
Right.
It's not going to be this big one. I'm going to put that one back where it belongs. But, I mean, these little coils are pushing this big thing like it's nothing. It's like not a big deal, but it's awesome to watch it happen. $35 in. Light's getting bright now. 687. 708.
Awesome.
Thank you. But I love how this continues to increase. I mean, after 5 seconds, that one's done. It's where it needs to be. $722.
Nice.
And our light is getting very bright, but it still has a lot of brightness.
Yeah, it does.
But I mean, the last time I had it hooked up, it was hooked up in a loop with another pulse motor. That may have something to do with the amount of power. Oh, 722.
So you want to talk about the memberships that we have available?
Yeah, we've got student membership, which will get you access to the Discord and our emojis, which are pretty neat. It's a couple rotors and a couple pictures of me. You know, like if you want to do something like that, it's not me doing Uncle Sam or anything, but it's, you know, look and smooth. I think were the two emojis. With my picture, and then never mind. We got 10 levels, badges that you can get on different month for your memberships, and we've got student, apprentice, and master for the levels of membership. Now, master will get you a free 3D print. And it'll get you access to the workshop and Discord. We talk about ideas. So many ideas flow through here that it's really a knowledge database.
Yeah. Through the videos and the people watching them. Yes.
Right. Absolutely. And yeah, so what I'm getting at is there's different levels of influence that you can have. If you get into the workshop, you're like hands-on with what's going to be built next, and like you get a big say in what basically I'm going to end up doing.
Yes.
And you know, if we get any like master members, it'll be like Knights of the Round Table kind of thing, where everybody's at the head of the table.
Here's some of the 3D prints that we have now. You can send in your own design.
Currently, there's no like format for. Well, I don't know. I forget what I was gonna say. But there's like no.
Or we're learning how to do it. Or there isn't a format at all.
Well, on how we're going to incorporate our next build, really, there's no like format on how we do that. But everybody that wants to say, like, all the ideas that come through on the chat here and super chats and all that, that is all compiled and considered in databases.
Mm-hmm.
But I mean, if the master comes by and he says, you know, I've done this 100 times, this is what's really going to happen. You know, I gotta like kind of, it's a dumb example, but I kind of, you know, I gotta scratch my head and say maybe he's right.
So one of the reasons,
I'm just trying to demonstrate an influential, you know, reason to be a master.
right, no doubt, and that would,
It's more about,
you're not required to have any background experience.
right, you don't need background experience. You don't need to know what you're doing even. You can just have an idea and blurt it out. A lot of people do.
Yeah, there it is. There's a lot of ways to look at this
I do it a
because
lot. I do it a lot. Like this, it took me all night to get to where this is spinning like it is. But now that I got it here, it's like moving.
yeah. So that is so hey everybody, welcome to the channel. Drop a like, subscribe, leave us a comment.
Check out the light right there, bro. Heck yeah. I'm gonna turn off this one too, and we'll get an idea. There we go. Yeah, so what a pulse motor does is it spins and it makes electricity. It uses electricity to spin to generate electricity, and the idea, I guess, is to get more electricity out of it than you put into it. Which, as far as I know, from what my buddy was telling me, is that that's not a thing. Really, it's not. Because like, and even in transformers, it's not even about the amps switching, but it is. I mean, it is in like a standard transformer, but in a transformer like this, it's all you got. There's a whole other equation for how much copper is on one side of the equation and how much copper is on the other side. You know, like if you have 100,000 turns in your transformer and your generator side, and you only have 600 turns in your that's what happened over there on that side. If you only have 600, then it's gonna look like you're putting in way less than you're getting out. But seriously, when you do that ratio math, you're right back down at ground zero or less.
Hey, Elk, can you translate to English? And welcome to the channel, and thanks for dropping a comment.
I have an Utron.
Nice one. Oh no.
I have an Utron, an aluminum Utron coming in the mail. If anybody that doesn't know what an Utron is, it's two cones that fit together at the bases, and then all three dimensions are the same, so it's cubic. But at the same time, it's two cones. So you look at it one way, it looks circular, you look at it the other way, it looks like a square. And I got two different variations of those. I just got two that I'm going to have coming. One with a nub for a bearing, and one without, and one with just a point for a bearing. A different kind of bearing. Yep, 722 is a very steady speed for that. And it's 75 volts, or I mean 35 volts. Turn it down. I think that's awesome. What's going on here? All right. I don't know, maybe we've had enough.
Hey everybody, welcome to the channel.
Hey, what's up, guys? So I wanna get my skeletal print for the rotor. So every other one of these is gonna have one of those Utrons in it that's an inch big. And every other one is gonna have 2 millimeter aluminum foil pressed around it.
Yeah, that's it.
It's a Zodiac with every other one being covered in aluminum and every other one having an Utron in it. I don't know if it's going to be like this shape exactly, but it'll have the 12 spokes in a different compartmentalized pretty much. If not the spokes themselves, they'll be the compartments. There'll be imaginary spokes there. Oh.
Something bothering you, bro?
Me?
Yeah.
Nah, man. Well, something bothering you?
No. I know what's going on. You were real deep in explaining something. So everything's good.
I don't know what's going on.
Why are you bothered?
I'm not really bothered. I just don't know what's going on. It's like I can't kick. Oh, never mind about it. It's all right. I'm been up for a while.
Yeah, stayed up all night.
Well, I couldn't sleep. I mean, the minute you left, I was in bed ready to go to sleep, and then they had the bass on way up. And I had to get up and tell
Oh,
them to turn it down, and then I couldn't get back to sleep.
yep. The kiddies. Oh, don't give them any ideas.
Oh yeah, Surge. Oh, Jolt.
John.
Yeah, man. So the pickup isn't bad for this. You just have to jump it. You have to start it at like 25. The other one you could start it at 15, and it would just instantaneous. But I have to re-hook that up. I might make. I gotta move this coil back over there. There's a lot of things that I need to do to check that out. I just don't know if I'm ready or if I want to do all that. I'm kind of exhausted. But the company that I had make the Utron for me, or 3D print it for me, is PCB Way.
All right.
Oh, and I can't wait. The first iteration was 1.5 inches, and I don't think it would have fit in the holes the way I would like it to. And I can't make the rotor any bigger right now because my only working 3D printer is got an 8.66 inch threshold. Now, we're gonna hook this up.
That's what I'm hearing.
Yes. Something good. Yeah, yeah. 3D printed pulse motors channel. This is sponsored by them, and I think that he's got some of the best pulse motor builds that I've seen. I haven't seen all of them, but I've seen a lot, and his are pretty good. And I know that he rounds up all the different components and he puts them together in 3D printed stuff. And I think that's a really awesome idea. Yeah.
Yep.
Yeah. 3D PPM. Now there's a lot of other pulse motor channels that they utilize different things to build with. Yeah. See, I know Sky more for the coils from 3D PPM, and I know PCB Wave for their 3D printing from the same party. So he's actually helped me out a lot. Oh yeah, that's right. I need to get.
Hey everybody, welcome to the channel. Thanks for stopping in.
There's like spider webs of glue just all over everything in the middle there.
It's Pulse Motor Mayhem.
All right, now let me get that off there.
Yeah, definitely check out Peter's channel. He's
Yeah, Peter.
very resourceful if you guys want to get started with some old without having to buy anything. My
He's
goodness.
got great videos, man. His videos are very entertaining.
I shouldn't say that. To get things for cheap and make them useful.
Scavenging is some of the best way to get some of the best stuff for the cheapest price. Yep, that's the one right there. Peter Hall Effect 2.0. We got the gyro moving. So the contacts aren't exactly right, and the duty cycle is about 95%. But, you know, it works. It can work better, but it works.
Wow, the old transistors are better.
I agree. At least the bigger ones do, for the most part. And this was described in a special way through a comment. It's like I forgot how he mentioned it.
A union.
Well, no, I can't think of it.
Oh, you good. Yeah, you'll have to count how many experiments you ran in this video.
If I can, yeah, think about it. But yeah. Like how many rotor changes, how many coil changes, how many different readings and whatnot.
Yeah, the counter-rotating gyro motor.
Counter rotating, I believe that was it. 350. Wow. Oh. Oh. That makes sense. It's not hooked up. Because I need 2 more connectors to hook up the freaking thing anyway. Alright. Let me get those. I'm going to be playing with it just for a little bit. So I'm going to turn off the power. Just glue off of here. I'm going to have to fix this commutator. You might want to check how this brush, I mean.
Sorry for shaking so much there, guys.
You starting to shake?
Yeah, I had a lot of coffee this morning. We're good though. There it goes.
Yeah, it's still too close. I was trying to move it without bending it, but now I think I should bend it a little bit. See how it's really into the center?
Yeah, the wire.
Yeah.
It's that one that's going along the bottom.
There we go. That's kind of better. It's getting caught on stuff though.
See the arcing.
See, the 24 gauge wire has the best resistance in it for this, so it'll not cause a lot of friction, but it'll press down on the contact plate enough so that you get the charge. But I gotta come up with a better way. Gotta come up with a better way. Hey, Mama.
Mama said, "What's up?" Nice. Mom's got to be happy. How's it going, Era? Let me know if I'm pronouncing that right. We are working with pulse motors today. And this is counter-rotating gyroscope pulse motor.
That looks good. I'll go for a little bit. Wow, it's hot. Oh yeah, it's usually running at like 63 volts.
Oh, this. Oh yeah, the gyroscope. Yeah.
Yeah, that's right. That's how we do things.
And we're running at 39.
We gotta get the NASA rejection first. That's the important part.
Yes. Because that's where the credibility comes.
failed, impressively failed. I mean, how talk about the wrong stuff.
Well, I mean, yeah. Never mind. We don't got to talk about what's going on right now.
Is there any way to like make it contact more? I mean, maybe I could rough it up again with the
Sandpaper.
sandpaper.
Something's happening. Oh, that's this guy.
I wonder what would happen if we turned it up to 63 with this thing hooked up to it. Probably blow up both transistors. Oh man, I forgot what I was doing. I think, it's almost like I had a stroke.
Let me know if you need me to call 911.
Oh man, probably a couple months ago.
Excuse my language.
Oh man. What's up, Caleb?
We are
Getting there.
Yeah, within a half an hour probably.
So there it is at 63.
Yeah, it's definitely gripping it.
I think there was glue on there somewhere. That's all right.
Yeah, I can't wait for the new one because you proved the concept.
Well, I haven't been able to move aluminum with an electromagnet yet.
Okay.
And I think I need bigger coil to do it.
Okay.
No.
Hey everybody, welcome to the channel. Drop us a like, subscribe if you like pulse motors and magnets. Drop us a comment.
If you like mayhem.
Boom! Pulse motor mayhem. That's a beautiful look at it.
So there's definitely some added resistance on there right now. So I'm going to have to take the cap off, and I'm going to have to clean off all the glue.
All right.
Because, moving all around here, gluing stuff around here, these little threads have gotten caught up in there. I'm sure if I clean it out, it'll work really, really good.
Let us know if you guys have any questions. Let us know if anybody's working with magnets at home. That's a very good question. I'm not hungry right now. So next time I'm hungry, I'll go out and no, I'm just playing.
Oh yeah, man, I need to get the oscilloscope hooked up, man. That's what I need to do.
That thing is flying.
This thing?
Yeah, you can just hear it humming.
I'm gonna turn it off real quick. I'm gonna get those clips.
You can hear the motor powering down.
Now when this
Well, hold on. Andrew asked a question,
yeah.
and there is a little bit of both functionality and fun.
Yeah, I mean the purpose of a pulse motor is to generate electricity and to function as a motor. And that's what it does.
This was on a minute ago, but we just
Yeah,
cut
we
the
don't-
power out.
Yeah, we don't need to worry about it. I'm gonna hook this up. Hold on, Wonder.
So this is a motor, I think.
That's the supply, power supply.
Goes by electricity.
Yeah, plugged in.
So I'm not even really looking at it right now, but I mean I get your point.
I get the point why those letters
It's very fun.
not there.
Yeah, he started out purely out of passion for magnets, and then it turned into applying some practicality.
I just knew that I could spin for fun something without having to spin it myself. I began exploring ways on how to do that. My first one was a reed switch. Way before Hall effect, way before transistor, way before any of that was reed switch.
I remember this thing with this thing. How much glue is over here?
A lot. Wonder a lot. All right, here we go.
Andrew said my father and I used to build coils and stators from homemade generators.
That's awesome.
Started with push rod style. Yeah.
Oh wow, you started it push rod style? I mean, just looking at that stuff boggles my mind. Like how you get them all uniform and pushed through. It's like, looks hard. But I guess it's not that difficult. Maybe it's fun even.
Yeah, Peter, I like how you guys are, or how you're sharing your knowledge and we're able to duplicate it. So I love that stuff. And we came into this, well, I still have no background experience. I'm learning as I go here, but he's definitely self-taught and then learning from the community in real time. So no background.
Yeah, we're gonna look at something pretty cool.
You can say hi, Caleb.
Why? Hello.
Hello.
I'm picking up the glue because it's too much.
Thank you for helping.
So I want this brown stuff too.
Yeah, that's this stuff. It's all trash, so just keep it all on the side.
It's hard to pick off glue on here.
Yes.
So that has more room to put electrical stuff.
Agreed, Peter. This is cool and it's fun.
So I made
This is
my
the
own
one
one.
we need. And then I'm gonna have to get the light, the LED.
Hey everybody, welcome to the channel.
Hey, how's it going, everybody?
Drop-
Alright, let me check it
Drop a
out.
like, subscribe, leave us a comment, let us know if you got a passion for magnets or a hobby that you do at home.
Down one of these.
Nice.
You want me to move the fan out of the way for you, Wonder?
Oops.
No, I'm good. The fan's perfectly fine. So I got like a yellow pan reader because one time I was painting this
Mm-hmm.
and a yellow thing got back here and it dried up. It was like a chunk, like a small mountain,
Okay.
and then it melted, and now it's like that. It's flat.
It melted.
Well, I picked it off technically.
Okay.
I threw it away.
Well, was it fun?
Yeah.
Can
Okay.
you give me a roll of tape, Wonder?
Got it.
Thank you.
Can you give me the assembly line? Assembly line.
No, we don't want that there. It's a logical place for it to go, but that's not what we want. I'm gonna put it right here next to the oscilloscope, okay?
It doesn't stick.
Watch this right here.
What? It's gonna light up. Yay! It's on.
And then we'll see the sine wave. Hold on. And right when it gets to the center, it cuts off. Above it.
That is a strong freaking wave, dude. Electromagnetic field. So strong.
And
then poof.
Peter's channel does a nice job of explaining this, and we've been able to replicate.
Now I'm gonna take the same rod and I'm gonna put it like this. Look at the light, Caleb.
2 hour mark.
Nice.
So I can literally reach out 4 inches, maybe 5.
Get where his hands are. There we go. So he's got the coil in his hand. And then try to get the light and his hand in the same. And the light. We got it. There we go. Nice work. Okay, now you can go around.
And then when you do without the coil, without the rod here, you can get it right up in there
Go right in there.
at 0 point and then it generates. That's awesome. That is literally a picture and it's negative in the same motion.
Right, back on the camera duties. Thank you, Caleb.
You the man, son. You the man. All right. So that was pretty nifty. I always thought that was cool since I seen it. Turn that off. Here's the McDonald's wave again. As soon as you turn the light off, it goes square to McDonald's.
Hey everybody, welcome to the channel. Drop us a like, subscribe. Any questions about what we're doing, let us know.
This is very magnetic. I love it. This little rod here is probably going to be one of I don't even want to use it as a shaft. It's so awesome.
So I got about 15 minutes left.
Yeah, I don't even know if I have that much.
Okay, so then we'll wrap it up here pretty soon.
I know the benefits of having the trigger coil inside the coil is that you can put the coil anywhere and it'll fire at any time.
I'm back. I got my own stuff.
You get thumbs up for that, but you won't get this power out of it. You won't get that. At least not the standard way of driving. You won't get it. There might be some circuitry that you could put together that'll get it for you, but that isn't what I don't know. I might buy a few of those circuits.
You want to do a quick recap?
And then reverse engineering. So I'm making these bifilar coils, and what we've been doing all day is testing those. We've been testing the oscilloscope readings of this generator coil, which is 18,000 turns. So 2,000, 2,000, that's 4,000. 4,000 ... 18,000.
There we go.
You got one?
Yeah.
You want to join us? With the pulse motor?
Oh, I love it.
Way to go, Wondro.
Yes.
That is phenomenal.
It works well.
I'll try to get well.
So we're reaching now 400 volt spikes.
Thanks, Peter. Have a good day.
Thanks, Peter.
Good idea.
So basically what's going on here is you got two of my bifilar coils that are 1,000 turns of 30 and 1,000 turns of 26.
Paper is useless. I thought it was
Hooked up to
useful.
one trigger coil that is outside of the coil. It's going to take me an hour to explain that.
I took the paper off because it was useless. I was slowing it down.
Awesome.
Look at him go.
That's awesome. Yeah. All right. So yeah, that's what we've been doing, and I tested it like 4 or 5 different ways, 4 or 5 different rotors.
Oh yeah, we got these. We tested these guys.
They're very good coils,
Feel free
in my
to
opinion.
watch through the live if you want to see some of that.
Now you just need some circuitry to make them function better.
Got mine.
You know, they can. The pulse motor can go way faster than mine do, by a long shot. I'm glad mine don't go that fast because they would fall apart, literally. So yeah, 15,000 RPMs. Go for it.
Rock and roll.
Rock and roll, man. I want to see that.
I'm gonna try something.
But this is 25 volts in, and I'm pretty sure it's going about 600.
Got in. It's about strong.
617. Nice.
But it's generating, you know, peak voltage of 400 volts. And that's just on this coil right here.
So I'm writing down the volts every time I see them.
Writing them down. You're a great
25.7.
pulse motor lab technician in training.
So currently with the 1-inch air gap, we're generating 121 volts.
Oh, this one doesn't work properly. So I go to the moon.
That's a very substantial air gap.
How's it going, Pfeiffer?
Hi.
Air turbine, we got it. We are in the process.
We need to get a flywheel for it.
Yep.
And I've always had that.
Oh, let's show you. We just printed this one out, Pfeiffer.
We got a pen now.
Excuse me, Pfeiffer. And this one, when it's going fast, it looks
Really cool.
quite remarkable. Take a look back earlier in the live to see it
You got
at full speed.
written.
Very.
25.7.
I mean, honestly, it's gonna have to undergo some physical changes. I have a few acrylic discs left to build another one. I want to make it so the air will channel through it easily. I think maybe I'll just drill bigger holes, because the holes that I've drilled are like less than a quarter inch. They're really small.
Yeah, these guys.
So
And then we are looking to hook up a hydraulic loop into this.
yeah, hook up something to the shaft and spin that, and also to have it encased maybe, or to have it loop back. Not even encased. I'm not going to encase it. I probably should, but I'm not going to. But if I can have it, the air channeled back just enough to make it move more, I consider that a win.
So I'm ready.
Well, if I can get it small enough, I'll encase it.
Yeah.
And that's small enough, but I mean, I'll get it in there so
Excuse me.
I can recycle the air.
Slow down, but I got the highest window on.
You're documenting everything? Good job.
Thanks.
So it said 55 OL on that one.
That might actually be useful in the future. Posting the data in the video.
So I got these little rotors.
Oops, sorry.
I got two of these, and they spin. This one doesn't spin very well, but the other one spins really well. And they're 12 magnet rotors, well, 12-sided rotors, so I can put 12 magnets on them of this nature. So you screw them in. Yeah, but I know it'll spin.
51.
I don't have to put 12 in, is what I'm saying. I have options. I can put 4 in, I can put 2 in, I can put 6 in. I can change it after I built it. It just has 12 sides, so I have options.
And there we go.
Oh, wow.
18.64, 18.64.
All right.
Yeah, Pfeffer, it's got to be late there. Nighttime. And we are just about to call it. See, he came in right when we were about to sign off.
18.64.
I got it.
We're done with the voltage. It's time to just flip it over and do something else.
Good job.
Oh man, it's getting muggy where I'm at.
Yeah. Yep, 10:30. Yeah, that's what I figured.
I got something.
Drew, we've had a few countries in the house today. Yeah, I can't wait for the parts for that to come in.
Me neither. That way I'll know that they are the right parts. Utrons, little cone, double cone, mirror-shaped cone-shaped things that are the same dimensions on all three.
All right, my man, you want to give a Pulse Motor Mayhem Papa Bale sign off?
Yeah, so thank you everybody for coming down. I really appreciate you being interested in pulse motors and everything else. Hopefully I can show you guys some stuff that you enjoy seeing, some stuff that you haven't seen before, and some stuff that you want to see again. Alright, so thank you very much. Please like, subscribe, and have a wonderful night. Thank you very much. I really appreciate it. Bye now.
You want to say bye too, Caleb?
Bye.